Page 21 in the Unit 1, Topic 3 packet, graphs of rational functions, equations, expressions. And this one has instructions that says, evaluate the following limits. So we're back to limits again, i.e. find the y coordinates of the whole. So that's your clue about what kind of limits we're going to be doing in this page of the homework. So we're given a limit as x approaches -3 of a rational equation. And just as we did in the previous page, we're going to be doing some factoring to see if we can find if a whole exists. So I have a canceled factor of x plus 3 and in the numerator and denominator after factoring by split the middle of the numerator. A canceled factor numerator and denominator indicates a whole. So what I'm going to do is basically divide to 1. So all I'm left with is x minus 2. That allows me to plug in what x is approaching, which is -3. There is no vertical asymptote because there is no factor in the denominator after canceling the common factor. So the whole is at -3, x plus 3, the canceled factor is set equal to 0, solving for x is -3 for the whole, plugging -3 into the uncanceled part of the equation gives us -3, -5. So since it is removable discontinuity, a limit exists for that kind of discontinuity, and it exists at the y value of the whole, which is at -5. Notice that for the limit statement, I have, rather than write the entire equation again, I have set each equation equal to g of x. So when I write my limit statement, which you must write correctly, I'm just saying the limit as x approaches -3 of g of x, just to save some writing time. But at least try to write it that way if you're not going to write the whole rational equation. Factoring again for b, split the middle for top and bottom, common factor, numerator and denominator of x minus 3. That's where the whole is. This one does have a vertical asymptote at x equals 2 by setting x minus 2 equal to 0. But remember, there is no limit for the vertical asymptote because it says the limit as x approaches 3. If it's approaching 3, that's the whole. That's the only limit statement you need to do. Take your whole, the x value of 3, plug it into your equation, into the simplified rational equation. You get 5 as your y value, and then since it is removable discontinuity, the limit exists as I approach that whole from both the left and the right. Letter C says that I need to factor only the denominator by difference of squares. When I factor it by difference of squares, I eliminate the common factor of x minus 5. That does leave a vertical asymptote of x equals -5. But again, we are doing limits around point discontinuity. So the canceled factor is x minus 5. Therefore, the x value of the point of discontinuity is 5. Plugged into the equation, the y value is 1/10. When I eliminate the numerator in this equation, I am only left with 1. X minus 5 into itself is 1. X minus 5 into x minus 5 is 1. That leaves the numerator at 1 and the denominator at x plus 5. That's how I get 1/10. 1/5 plus 5. and it's point discontinuity, so the limit from the left and right agrees, so the limit exists as x approaches 5 of g of x, and it's the y value of the whole, so it's 1 over 10. Factoring letter D, difference of squares, this time in the numerator. Still a canceled factor, numerator and denominator. This time there is nothing left in the denominator, so I'm only left with x minus 1. The common factor indicates the x value of the whole, x plus 1 equal to 0, so x equals negative 1 for the point of discontinuity. Plugged into the equation, x minus 1, negative 1 minus 1 is negative 2, becomes the y value becomes the answer to the limit left and right. G of x for letter E, letter E is a little tricky because if you look at the numerator, it doesn't seem like it's a factor like the other problems we've done. You're going to have to get used to rearranging these binomials in a way so that you can find common factors. So the factoring I did was, first I rearranged 3 minus x to be negative x plus 3. And then in order to find a common factor with the denominator, I factored out a negative 1. When I factor out a negative 1, that leaves negative parentheses x minus 3. And now I've got a common factor, numerator and denominator, of x minus 3. Simplified further, that leaves negative 1 over x plus 3, which when we're doing the y value of the point of discontinuity will help me plug the x value of the point of discontinuity into the simplified equation. So the whole is at x equals 3. Plugged into the equation, it's negative 1 over 3 plus 3, so it's negative 1/6. So our limit from the left and right agrees. Limit as x approaches 3 of g of x is a negative 1/6. Letter F can be confusing, but you have to remember your exponent rules. E to the 2x is kind of like saying x squared minus 1, because e to the 2x is e to the x times e to the x, because you add the exponents, so x plus x is 2x, so factored. E to the x plus 1, e to the x minus 1. So this is like difference of squares, just like we did above, or like the denominator in letter E, difference of squares. So now I have a common denominator, numerator and denominator of e to the x power minus 1. When I divide those out, I'm only left with e to the x plus 1. So the whole in terms of how I find the x value is, well, first of all, I add 1 to both sides to get e to the x equals 1. And then if you remember from either Miss Strauss or Miss Weiss, we talk about the crossover method of solving or changing, or Roman numeral 9, changing something exponential into something, into a log. Anytime I have the power of e, the inverse is natural log, so it becomes ln of e. The 1 crosses over to be the argument to the natural log, and the x or exponent crosses to the other side. Anything raised to the 0 power is 1, so your exponent answer for the natural log is 0. 0 plugged back into e to the x plus 1 becomes e to the 0 power plus 1. Anything to the 0 power is 1. So 1 plus 1 equals 2. And so my limit statement is going to be the limit as x approaches 0, because that's what it says. Oops, that's what it says here. Is the limit as x approaches 0 of g to the x equals 2. Two more to do. I'm going to skip I and j because those are really no different than any of the problems above. G is going to be factorable via greatest common factor, no factoring of the numerator. When I simplify, I am factoring an x out of the denominator, so the numerator and denominator cancel out a factor of x, so it becomes 1 over 3 to the x minus 1. That's our simplified rational expression. Since the factor I'm canceling out is x, x equal to 0 is my x value of my whole. 0 plugged into 1 over 3x minus 1 is 1 over 0 minus 1. So 1 over minus 1 is negative 1, which becomes the answer to my limit question since it's x approaching 0. Last one, H, is very similar to our problem e to the 2x minus 1 above in terms of our factoring algorithm. This is also sine squared x minus 1 is also a difference of squares. You should remember from last year that sine squared x is the same thing as saying sine x times sine x. So if you think about it as difference of squares, it's going to factor into sine x plus 1 and then sine x minus 1. And the denominator stays the same. But the sine x minus 1 in the numerator and denominator, they divide out to 1, leaving only sine x plus 1. And then this one is a little bit confusing because you have to remember what you learned about inverse sine. So I made a little baby unit circle here below. And my question became, if I have sine x equals negative 1, then I need to do the inverse. The inverse of sine is arc sine or inverse sine. So that inverse sine of sine x equals x. And then in my calculator, or using my little abbreviation of the unit circle below, I can see that the inverse sine of negative 1 is negative pi over 2. So I actually think that there is an error here. I think that that should be saying as x approaches negative pi over 2, like I wrote over here. And since x is negative pi over 2, the y value is negative 1. So our limit statement is going to be as x approaches negative pi over 2 of g of x, the answer is negative 1. So I'm just going to expose the last two answers since they're not very much more complicated than E and H, or F and H that we did above. So this one is split the middle on the top and difference of squares on the bottom. Canceled factor is x plus 2. Plug negative 2 into the simplified equation to get negative 1/4. For I, split the middle for top and bottom. X minus 3 is the common factor. Set x minus 3 equal to 0, so x equals 3 is the x value of the whole. 3 plugged into the Simplified equation makes it negative 1/9. So our limit statement becomes the limit as x approaches 3 of g of x equals negative 1/9. I hope this helped, and I will see you guys soon.